Thank you. 406 Module 4 Review and Practice Exam. That's what I'll be doing today. I'm going to work through the problems and explain how I come to the answers, so you can use this as a nice study guide before you take the tests, which is not due till the Sunday after Thanksgiving break. So if you're working on it early during Thanksgiving break, good for you, getting ahead, because this is what's going to be assigned the week after Thanksgiving. So the Module 4 Review and Practice Exam. Let's start with this. A triangle JKL prime, so that is the larger one here, is a dilation of triangle JKL. JKL prime, JKL. Using the origin as the center of dilation. So here's our center. What scale factor was used to create this one? All right, well, let's do that by looking at the points. So point K, let's look at K. K is 2, 4. And K prime is 4, 8. Well, we know a dilation works by taking a point XY, and it will take the scale factor, whatever the scale factor is, and multiply it by the X and the Y, the same scale factor. So what would the scale factor be to make 2 into a 4 and make 4 into an 8? Must be a multiply by 2. Let's go ahead and check another point just to be sure. L, let's look at L, 6, 3. If our scale factor is correct, this should be 12, 6, right? 12, 6. Yeah, that's what it is. And since it already said it was a dilation, we really don't have to check the third point. We know it should be the same since it told us it was a dilation. We're just checking for scale factor. Scale factor of 2. All right, let's move on. An artist designed a badge for a school, and so figure ABCD on the coordinate plane shows the shape of the badge. All right, so we have this trapezoid-looking badge. The badge is enlarged and plotted on the coordinate grid as figure JKLM, and we have J and M, which should be corresponding to A and D on the other triangle. Point J is located at 1, -6, because it says A, B, C, D, and then it names it JKLM. So that means A and J are corresponding. So that's this one and this one. So M and D correspond with one another. So that is this side over here. Let me just highlight that. This would be the same as that. It looks like it, but verify. Good thing. All right. Point J is located at 1, -6. Yep. J is at 1, -6. And point M is at 3, -2. Which of these could be the coordinates for point L? Okay, so we have to figure what was the size. How big did the size change? Let's look at that. This went from 2 down, 1 over. The length of AD, is equal to, let's use the distance formula, -8, 5. A is -8, 5. And D is -7, 7. I'm doing this a little more complicated than it could be, just to go through some of these other things we need practice on. So let's do D minus A. So 5 minus, oh, not negative. 5 minus 7 squared plus -7 minus a -8, which means plus 8 squared. So that equals the square root of 5 minus 7 is -2. -2 squared is 4, because -2 times -2. -7 plus 8 is 1, 1 squared. So that equals the square root of 5. That's how long AD, the length, is. How about J to M? So J, we said, is 1, -6 and 3, -2. So the length of that would be, let's do -6. Let's do this straight. Let's go M subtract J, because that's what we did here is DA. -2 minus a -6. So that's adding 6. Minus a negative adds. and then 3 minus 1 squared. So this will equal negative 6 plus 2 is 4 squared, and that's 2 squared. So this equals 16 plus 4 square root of 20. And the square root of 20 simplifies down to the square root of 4. Oh, yeah, I'm going to do it this way. Times the square root of 5. 4 times 5 is 20. Square root of 4 is 2. So this is 2 square roots of 5. So the length of this is a square root of 5, and this is 2 square roots of 5. So this is twice as long as that. This is a scale factor of 2. It's twice as long. We could have done it more simply by going over 1 and down 2. This goes over 2 and down 4. We can see that's twice as big. Over 1, over 2, down 4. So it is a scale factor of 2. Scale factor 2. So point L, what does L correspond with? L goes with C. So since C is right here, M is right here, there's a distance of 1 between there. It means there would be a distance of 2. So it should be right there, which is 5, negative 2. 5, negative 2. Okay, do a little extra work there just to practice some of our other skills. But as long as you figure out it's a scale factor of 2, and then know that that side should be twice as long as that side, and to get that correct, you'll be fine. Okay, parallelogram FGHI on the coordinate plane represents the drawing of a horse trail through a local park. Making some sharp corners and some other ones. In order to build a scale model, the drawing is enlarged as parallelogram ABCD on the coordinate plane. If 2 corners of the trail are at point 0, 4, so here's 0, 4. It's right there, and negative 6, negative 5. What is another point that can represent C? Okay, so again, we need to see what goes together. F, G, H, I goes with A, B, C, D. So C corresponds with H. Those are in the same order, same position. So we're trying to find this point. All right, so we need the scale factor between this right here and the original. I can go ahead and draw it on there just to make a nice visual for us. Okay, so this corresponds with this side. So this one's over 2, 1, 2, and down 3. Over 2, down 3. This one goes 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm taking the shortcut this time. We did it the other way last time. So over 2 and down 3, over 6 and down 9, that would be a scale factor of 3, right? Times 3. Scale factor 3. Okay, so how long is it between these 2 points? 1, 2, 3, 4. It's straight horizontally over. So if that's 4, this should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12 should be right there at 6, negative 5. 6, negative 5. And we can make a scale drawing of that. All right. Bradley and Kelly are out flying kites in the park one afternoon. A model of Bradley and Kelly's kites are shown with the kites Brad and Kelly. Oh, they misspelled Kelly, respectively. So this would be Brad, and this is Kelly because it said respectively. So it'd be left to right, which is correct. They are similar because the corresponding sides of the kites, Brad and Kelly, all have the relationship of 1 to 2. They're not similar because all the corresponding sides have the relationship of 1 to 2. They're similar because they have a relationship of 2 to 1, or they're not similar because they have a relationship of 2 to 1. Okay, so every one of them says that they have corresponding sides. It's just, are they 1 to 2 or are they 2 to 1? So if this is down 1 over 2, that would be the same. This is the same as this. So it's 4 and 2 rather than 2 and 1. So they are a relationship there, but Brad's is the smaller one. So his would be 1 to 2, right? Because this is twice the size of this one. It's a 1 to 2, Brad to Kelly. All right. Smaller ones on the left, the bigger ones on the right. It's a 1 to 2 relationship. And since they are all a 1 to 2, they said all the corresponding sides are, they all have, that's not even an option whether or not they all have. So we don't have to check them all because it says they all have that. Definitely, it's not the 2 to 1. And they are similar. If all of those relationships are the same, if every one of these lines is twice as long as these, it is a similar shape. So 1 to 2, it is similar since all of the sides are proportionally the same. Proportionally the same. All right. Polygon PQRST prime shown on the grid is an image of polygon PQRST. So PQRST is the smaller one, and PQRST prime is the bigger one. I don't know how well you can see that on the screen, but there's little primes here next to each one of these. Okay. So these are the primes. Make that a little clearer. After a dilation with a scale factor of 3, with the origin as the center of dilation. So from this point, this is 3 times as long as this is. And this is 3 times as long as this is. And every point would be the same, 3 times as long as the shorter one from the origin, since that's the point, center of dilation. Which statement about corresponding sides and angles of 2 polygons is correct? So the measures of Q right there and Q prime are a ratio of 1. If this is 1, that's 3. That should be right. Let's check and see what else is going on. The length of side TS right there, TS is equal to the length of side TS prime. Are those equal? That's not a true statement. The length of diagonal RT, so from here, from R to T, is equal to the length of diagonal R prime T prime. Those are definitely not equal. The lengths of side SR, right there, and SR prime out here are a ratio of 1 to 3. Oh, here's what we're going. Okay, I got fooled. Don't do this. This talk about the lengths of the side. Those would be in a 1 to 3 ratio. This talk about the angle. I missed that, the angle. So the angle of this is being compared to the angle of this. All right. I was thinking the length 2Q and the length 2Q prime. That's not what it's saying. Angle. That's a very key word. I'm going to put a big pink highlighter on it. What happens with the angles of a shape when we dilate it? Did this angle get a lot bigger than that angle? Did all of these angles get 3 times as big? No, angles do not change in a dilation. Angles do not change. So this is not true. It's not a 1 to 3. The lengths is what's 1 to 3. It's a good thing we checked the rest of them. See, if I'd have just checked that first and go on, I'd have missed that problem. I don't want to do that. Check what it's saying. Angles stay the same. So it almost got me. All right, let's look here. The coordinates of quadrilateral EFGH are right here. The image of EFGH under dilation is EFGH prime. So if the coordinates of E, so E went from here to here, or 1, 2, what are the coordinates of H, which is right here? So what happened? We had 4, 8 became 1, 2. What was the scale factor? What did we multiply this by to get that? See, if we don't know, we can just take the original and put it on the bottom here, either one of them. I'll do both of them. and take what it ended up and put it on the top. It ended up a 1, it ended up a 2. 1/4 must have been the scale factor. 2/8 must have been the scale factor. Why do we have two scale factors? Those are the same number, right? Those are the same. 1/4 is the same as 2/8. So 1/4 is our scale factor. So 1/4 times 8/8. What would happen if we take 8/8? Well, we know 8 became 2 because 8 times 1/4 is 2. 2, 2. Yeah, to find the scale factor, if we know the points, the original goes on bottom, the dilation goes on top. Dilation over original. And that's true with the X or the Y. We could do the same thing with the Y. Or if we have a length, of a side, we put the length over the length of the original dilation, put the dilation on top. That'll also give us a scale factor. Lots of shortcuts there. Okay, number 7. Kyra's using a rectangular tile of 2 types for a floor design, and here's each shape. So we've got a plain one and then this patterned one here. Which statement's correct? They're similar or not similar because SRSP is 3-2, and this is also 3-2, PQ PR 6-4, and S9-8. Okay, so we got to look at this. So the ones that say similar have the same ratio. And if it is similar, the height and the length are going to be a similar ratio. So we got to check to make sure those are the same. And they're not similar if these are not the same. See, those are not the same ratios. So if it's a different ratio, then it is not going to work. So let's check the ratio. How tall is this? It went from 1-1 to 1-5. So that means it went up 4. It went from 1-5 to 7-5. So 1 to 7 is the length of 6. 2-1 to 2-7, it became 6. 2-7 to 11-7, that is 9. 2 to 11 became 9. So 4 over 6, right? Let's say whichever way we wanted to go. If it went from 4 to 6 or 6 to 9, let's say this is the original and this is the dilation. That would mean they're similar. All right, so if the original is on bottom, 6-4, which would be 1.5, right, or 1.5. This one, say 6 and 4, either 9 and 6, 1.5 or 1.5. So it is similar. The bottom would be the same because it's rectangular. This is going to be 9. That's going to be 6. That's going to be the same. So they are similar. So let's see. It says PQ. It used the bottom one, so that would be 6. PQ and QR. Oh, it's checking on the same one. Okay, so PQ to QR is 6-4. You can do it that way. And JK, J to K, and K to L is 9-8. It's not 9-8. This is 9-6. Okay, how about SP to SR? SP to SR. SR is 4-7. That's not 4-7. MJ to ML. MJ to ML is 2/3. 6/9 would be 2/3. That's true. But this is not 4/7. So neither one of those worked out. Oh, those are the not similar ones. Let's check the similar ones. SR to SP. SR is 6. SP is 4. So that'd be 3/2, which is 1.5. All right, 1.5, 3-2. 3-2, 6-4 is the same as 3-2. And ML to MJ. ML is 9. MJ is 9-6, which is the same as 3-2. They are similar. Because they have the same 3-2 ratio. Checking both shapes. Okay. Which we know is a 3-2 ratio. Three of these equals 2 of these. Triangle ABC is similar to triangle PQR. Here's ABC, here's PQR. Which ratio is equal to RC? Okay, well, let's see. R is this side here. And it's between the angle that is just plain and the one that has 1 tick mark. C, right there, is the same side. It's between the angle that's plain and the one that has 1 tick mark. So those correspond to one another. So that means the one between the 1 tick mark and 2 tick marks is P, and that would correspond to 1 tick mark, 2 tick marks, A. So P and A go together, and that would leave Q and B to go together. So equal, which one's equal to R to C? C to P. No, C goes with R. We already know that. P to A. P and A, I've got both of those orange. Those are the same. R to A, no, R doesn't go with A. R goes with C. And they use C and R in all of these. C and R go together. They don't go with any other letters. But that was real easy to prove because only one of those was even close and used a right side there. So, all right. Trapezoid, ABCD, is congruent. Congruent, that means exactly the same size. So AD is congruent to side what? Well, A, B, C, D goes with E, F, G, H. So A goes with E, D goes with H. So AD would go with EH. It's that easy. There you go. Are these similar? Are these similar? Okay, well, obviously they are lined up the same, so this side would be the same as this side. So that's a 2 to 5 ratio. 2/5. You can do it either way, 2 to 5 or 2/5 scale factor, 2 to 5. This is 2 to 5. Do it like this. This is 10 to 20 or 10/20. And this is 10/20. So 10/20. So is 10/20 equal to 2/5? Because we have two sides that are 2/5 and two of them that are 10/20. Well, 10/20 simplifies to 1/2. 2/5 is already simplified. So these got half as long or twice as long if you're going this way, depending on which way we're going, which one's the original, which one's the dilation. If we say here, it got twice as long, and if this went twice as big, it'd only be 4. So these are not similar. It says yes. Let's scratch anything. It says yes. It says they're not congruent. They're not proportional. The corresponding angles are not congruent. Angles. Well, we didn't look at the angles, but we know the corresponding sides because we have side lengths. We don't have any angle measurements. We don't have any angles. So we can cross those out just because they say angles because we do not know any angles in there to compare. So, but we know the sides are not proportional. It's a different proportion. This one's 1 to 2, and this one's 2 to 5. That's not the same. So pay attention to angles and sides. Don't miss something easy because they switched what they were looking on there. In the figure below, triangle ABC is similar to triangle PQR, as shown below. Okay? So they said A went with P. So these are the same, and they have them marked the same on the angles. And then B and Q would be the same. They have the 90-degree angle, and then C and R. What is the length of side PQ? All right, so what side do we know? We know one side there. We know the 80 from Q to R, and that's from the 90-degree angle to the double angle, the 90-degree angle to the double angle. So that corresponds with that. All right, and the side we're looking for is P to Q from the right angle to the single. So we're looking for this one, which we know is 16 something. So the little one was 20 to 80. Right? And this one is 16 to something. So this got, what, 4 times bigger. It's a scale factor of 4 if we went from this one to that one. It's 4 times bigger. So this would be 4 times bigger. 64. That would make them proportionally the same. All right. Triangle RST is dilated to create triangle UVH on the coordinate grid. You are given that angle T is congruent to angle W. That's because RST, UVW, again, these are congruent to one another, same angles. What other information is required to prove the two angles are similar? Similar. Okay. So segments are congruent. Well, if they're congruent, they're exactly the same. Now, you can have two shapes that are exactly the same size, and those can also be called similar. They're so similar that they're exactly the same, but that is called similar. But to prove that, what do we need that? Well, if we need that, we'd have to have a lot more. How about angle S is congruent to angle V? Or it also says S is congruent to U. Which one to be? S is V. So let me ask you, if I have a triangle, and I have another triangle, and I know that this is 40 degrees, and this is 80 degrees, and I know this is 40 degrees, and this is 80 degrees. Is that enough to prove that those are exactly the same triangle? Without knowing what those angles are right there? Well, here's the hint. All triangles equal 180 degrees. That is the nature of a triangle. The definition of the angles of a triangle. The triangle sum theorem says all angles add up to 180 degrees in a triangle. So if these two are the same, this one has to be the same as that, because this is the same and this is the same. So these have to be the same, because there's only one number that could make those equal 180, and it has to be the same number in both triangles. So proving that these two angles are the same is all we need to prove that those are similar. Now, again, they can be different sizes, but remember, angles do not change in similar shapes. If they get bigger or smaller, the angles stay the same. So that's all we need, is to prove that two angles are congruent, exactly the same. Okay, that's all we need. Oh, looky here, we're down to the end. We got 2 pages left, 3 problems. Okay, triangle STU is similar to triangle VWX. Which statement is true about these? It says this is congruent, this is congruent, this is proportional, this is proportional. STU VWX. S and V are congruent. That should be true. T and U are, well, that's in the same triangle. We don't know that. T and W are proportional. Proportional, no. They shouldn't be proportional. They should be identical. They should be congruent. That's the only one of those that's true. That's the one true. Triangle MN and O is similar to triangle PQR. Okay, M. All right. M and O. And I'm going to make it. I'm going to make it bigger to show it's similar, but not necessarily the same. And this is, let's see, M is the same as P, so that means P has to be here. N is the same as Q, and then R would be out here. So it says if N measures 85 degrees and P is 75 degrees, what is R? Oh, well, knowing what we know, since Q and N are the same angle, this has to be 85 degrees also. And since now we have two angles, 85 plus 75 is 160. It has to be 180. Last one has to be 20. By the same token, we can say that we know this one has to be 75 because it's the same as P. And so that has to be 20 as well, because it's the same as R. 20. All right. Are the two triangles below similar? All right, we've got, you can see that 38 and 58 and 84 and 38. Well, I don't know. Similar has to have two angles the same. And we have one angle the same. These are both 38 degrees. But this says 58, that says 84. Well, we know the triangle sum theorem says that all triangles add up to 180. So if this one is 38 and 58, that adds up to 96. So this other one must be 180 minus 96, or 84. 84 degrees, which corresponds with this one, which is 84 degrees. Yes, they have congruent corresponding angles. So this is 84. So this is 84 and 38. That's 84 and 38. So this must be 58. we could have done the same thing here. Add 84 to 38, and we would get 122. And 122 plus 58 is 180. So there you go. Take your time. Take your time. Make sure you know if it's talking about sides or angles, because it's different. Remember, with the sides on similar shapes with dilation, sides are proportional. You know, if this side got twice as large in the new shape, this side need to be twice as large in the new shape. Not 3 times or half or anything. Have to be proportional. But angles, whatever this angle is, the new angle has to be exactly the same. Right? This one has to be the same. And triangles add up to 180. Always. Or it's not a triangle. It doesn't work. It has to add up to 180. Otherwise, have a great holiday. If you're seeing this before the Thanksgiving weekend, Saskatchewan, I hope you've gained a few pounds. Had a good time off there for the break. Saw lots of family, good stuff. And anyway, do work you can be proud of, and have a great day.